My name is Russ Maxwell, and welcome to Hands-On Lab number 2. Feel free to subscribe to my channel, which will motivate me to continue building fresh content for everyone. I like to break down complex technical topics and simplify them when I feel it's necessary. This is a Hands-On Lab series where you have an Azure subscription, and I'll provide the rest to help you step by step building and developing the solution presented in this particular video. If you don't have an Azure subscription, that's okay. You can still watch this video and have a good understanding of how to easily implement logging and leveraging app settings for your Azure function based on the V2 programming model. These labs are more developer focused than infrastructure. For the infrastructure setup, I typically include a step-by-step setup in a wiki on my GitHub repo, and include links to those in the description. However, this lab, number 2, is a continuation of Hands-On Lab 1, where you set up and developed an Azure function which leverages Azure Key Vault and calls into Azure SQL database to fetch some records. That's what this flow represents in this slide. If you want to implement the exact steps in this video, you'll need to first run through the Hands-On Lab 1 in my previous video, and then come back to this one. I'll drop a link to that particular video in the description. If you just want to learn by watching and implement this integration in your own Azure function, that works fine. And you should pick up enough from this video to implement this functionality in your own Azure function. I'll be using Python, so I have an expectation that you have some basic knowledge in Python. If you're completely new to Python or little experience, that's okay. But I recommend to first go watch BroCode's Python training on YouTube. It's an excellent Python course to get you ramped up and ready to go. I'll drop a link to that video in the description. For this particular lab, I just have 2 quick PowerPoint slides before we dive into coding to provide some context into why we are implementing logging and leveraging certain app settings. Let's dive in. What is this logging thing about, and why do we need it in our Azure function? What if your expected outcome after an Azure function is to write some new records to a table within a SQL database? That Azure function appears to have executed without any errors, however, no records were added to the table in SQL. To add more complexity, each run appears to add records, while other times no records are added. So how do you figure out what's going on? Well, you have a few options. Number 1, remote debugging. So you can implement remote debugging and see if you can catch the problem during function execution. The second option is connecting the Azure function to application insights and add your own instrumentation. And that's a fancy way of saying your own logging statements within your code. Option 1, that's not the easiest, the remote debugging scenario. It takes much longer to debug your code to find root cause, and it's more of a manual effort. We're going with option 2. And if I click the slide, this is what we're introducing. I want to enable application insights for the Azure Function app, which enables me to send logging data from my Azure function to the App Insights resource. Any logging code I add will get sent to the App Insights to be stored as trace events within the Log Analytics database. This is great as it allows me to quickly review these logs. If my Azure function has errors in the future or performance degradation, or I just want to monitor the execution of the Azure function, by having these logs readily available, I can get a quick idea as to where the problem is within my code. In fact, it might not be my code at all. It could be some faulty REST API I'm calling. The point is having this logging implemented in your code provides details of what occurred during the execution of that function. Let's talk about integration, and this is on the infrastructure side. So integrating application insights with an Azure function is super easy. With an Azure portal, you'll access the Azure function, and under settings, you'll click application insights. And that's what this screenshot is. And then you'll select the turn on application insights button, and I did that, and this appears. So I chose to create a new resource. I gave it a name and hit OK. And then you get this prompt about, the changes will apply and it could cause the restart of the function app, which is fine. So I just hit yes. So that's it for the infrastructure aspect. Let's dive into VS Code and we'll start working on adding this instrumentation and configuring the settings in order to send our logging data over to Application Insights. All right, so now we're in VS Code. I'm using the same code as the first lab with a different function name. From a code perspective, you have two main steps to enable this Azure function to start sending telemetry data to Application Insights. The first step is setting up your log levels. You configure log levels in the host.json file. By default, I have a logging section, and everything defined in here applies to how the function app will handle logging. I have Application Insights specified with sample settings enabled. The sample settings, that will reduce how hard you hit Application Insights by sending a subset of the available logging events over to App Insights. In my case, most of the data I'll send is request data, which is excluded. So I should see all logging activity that I set up within my Azure function. Additionally, I need to define my log levels. This helps me control the verbosity of logging I want to send to Application Insights. So I'm going to copy the log level settings in. So this is kind of how I'm going to have it set. So just be sure you add the comma here, and then you can drop this in. So in this example, I added a default, the host.results, and function categories. The default category, this is the default logging level set, as the name indicates. Host.results, that overrides log messages from the host.results category. And the function, this overrides the default logging level for log messages from the function category. The logging levels are inclusive, which means if I have a log level category like function in my example, set to information for the value, that will also include warning and error messages. However, my default logging level is set to warning and will only include warning, error, and critical events, and will omit information level logs as well as verbose values. You have 7 different values you could set for each log level. So starting from the most verbose to the least verbose, you have trace, and that logs all messages. You have debug, that logs all messages except trace messages. Information, so that logs only information, warning, error, and critical messages. Warning, that logs warning, error, and critical messages. You have error, which logs error and critical messages. You have critical, which only logs critical messages, and then none. So if I don't want to send anything to Application Insights for one of the logging levels, I can simply set it to none. Even if I have added code in my Azure function to send logging events to App Insights, this won't happen if none is set. So you can think of this as a control mechanism, and it's up to you how much logging information you want to send and what level of log info you want to send. If I'm really dealing with a nasty issue, I probably will crank this down to debug log level, which will give me a ton of verbose messages. This is especially true if I add debug logging events in my code. Now that we have logging set up the way we like in our host.json, let's update our application to write logs to Application Insights. Moving back into my function _app.py file, I'm now in step 2 and I want to write the logging events that will be executed. First, I need to import the logging module, which I've already done on line 2. This module contains various functions that are used to send events over to App Insights. The function names typically correspond to the log level. So for example, if I want to send informational events, I can use the logging.info function. If I want to send debugging events, I can use logging.debug. So looking through this code, if this looks completely foreign to you, again, go watch the first video and you'll get up to speed. So I'll scroll down to where I start getting the secrets from Azure Key Vault. And perhaps I want to send an informational event that I may want to go check later in App Insights. So I can just type in logging.info and then pass in the string. What's the text I want to include? There you go. So super easy, right? And you just plug in what logging events you want within your own code. Scrolling down a bit, you can see I'm fetching the SQL authentication credentials from Azure Key Vault. Maybe I have some strange issues once in a while when retrieving the SQL username from the Key Vault. Maybe the Key Vault admin is making changes and they're messing with that particular secret. When I'm really in the weeds debugging like this application in this way, I may want to include that information as well. So in this demo example, that's fine to kind of showcase how that works and expose credentials, but you never really want to do that in production. But it's interesting and I'm curious, so I'm going to do it. So create some real estate here on line 42. I'll just add my login debug because to me, this is a pretty low level event. It's probably not something I'm going to want to use very often, but so retrieved the username. And notice I used an F string here, and that's because I need to stringify the username variable above, because that's what I want to send over and include in the string. So this is just this particular run. If I have debug log level set, which I don't right now, but if I did, that particular line would execute after fetching from Azure Key Vault. So you can see this offers great flexibility, and you can be very detailed in your logging without necessarily sending everything over. But if you need to debug your application and you need all those events, you can just go to your host.json and change your log levels. Another important thing to note is even though they won't get sent to App Insights with my current log level setup, they would still appear in the debug console if I'm locally running this application for debug purposes. So it still has a use. There is still a use case for this, especially for those local debugging scenarios. Okay, moving down a little further within this, notice I'm doing a try except. So if I come down to this except block, you'll see I'm doing the same thing. So I'm doing a logging.exception because I want to pass that exception and I need to provide details so that I understand if I do run into issues where there's an exception thrown, I can go check those out on the back end with the App Insights. So simple to do if you want to log an exception. In this case, I'm using logging.exception. So same thing, I'm passing a string. I'm including EX, which on line 46, that's the exception object has an alias. So I'm passing that alias in as part of the string. One thing to note, this will also, for local debug purposes, this will also throw, if there's an exception, will show up in the debug console as well. So, okay, moving down to the very last part where I'm connecting to SQL. I'm gonna add one more event here. I'm just for my own notification if I ever want to go and look at this. Within App Insights, I can kind of see where things stand. Did I make it this far, right? Sometimes debugging these events kind of help you know how far you made it in code, like especially if it's a large and complex Azure function. So feel free, be liberal when it comes to writing these events to make your life easier later on. In this example, I'm just going to paste this in, but essentially it's login.info connecting to SQL database. Super easy. That's it. So I'm going to save this, and I'm going to do the exact same thing I did in the first lab, which is I'm going to deploy this Azure function back up to my function app. So I can come down here, click on Azure. I'm already signed in, so that's great, or else I would need to sign in. So I'm going to get to my function app, which is lab AZ func, and I'm going to right click on it, deploy to function app. Deploy. Okay, my Azure Func deployment succeeded. Now let's test out the Azure Function. If you don't know your Azure Function, if you don't know the URL, you'll need to go to Azure Portal, click on your Azure Function, and there's a get URL. By default, the first portion of the URL is going to be the name of the function app, followed by .azurewebsites.net. So that's what I'm going to do. It helps I've done it before, obviously. And then I need to specify API, right? And then I need to specify my lab 2 function, right? Because it's no longer lab 1 because I changed the name. So lab 2 func. And then I want to pass that parameter, right? Because it's only going to execute if I pass in the parameter name as magic. So let's run it. Great, I have an exception. That's even better. So I can go look on the back end and see what happened. But I've noticed that, like, I don't know if anybody wants to comment why that happens. I'll be interested, so add comments. But I notice whenever I deploy an Azure Function to a function app, the first time I try to access and run it, I get this exception. So that's interesting, right? Because if I run this again, and voila, right? I didn't do anything on the back end. I didn't do anything in Azure Portal to make this magically start working. It just started working. So in any event, I had a successful run now. So we should see plenty of logging and app insights. So let's go jump in and take a look. Okay, we're in the Azure Function app. So I want to scroll down to the monitoring section and click on logs. And this is nice because it just has a link to the Application Insights resource. So I'll click it. And now that I'm in my Application Insights resource, I do the same thing. I can click on logs, and this will open up the connected log analytics workspace, which contains the records. And the way the log analytics workspace organizes everything are in tables. So you can see I've got these default tables that are here. And the events I send over, those are always included in the traces table. So if I want to look at the traces table, let's see if I have any events. I ran this less than an hour ago. So let's see if they're there still. And I'm the only one running this function. So it does, the events are there, so good news. Notice they are in descending order, so it starts with the timestamp of the earliest event at the bottom and works its way up to the top, with the top entry being the latest event. So it is important to point out you're using the Kusto query language or KQL when working with this data. So if you're not familiar with KQL, I'll include a link to some training I did a few years ago. It's on YouTube, but it'll get you ramped up fairly quickly. In my case, I want to just get specific data I'm interested in. I'm just going to go ahead and paste these KQL queries in I've written already, and I'll include those in the description of this video. So the first one I'm interested in is, and with this query, what I'm doing is I'm saying where the operation name is the Azure Function name. So the operation name column is going to contain the Azure Function name, and that's what makes this a pretty important column when it comes to querying log analytics, especially if you have a lot of different things writing to log analytics besides your Azure Function, right? So this is how I can easily do that. And then I'm also including a message contains executing, and that indicates that the Azure Function was triggered. Finally, I use the project, and these are all the columns I want to display back. So let's go ahead and run this to see all the other Azure functions that I've started within the past, it's been a little while, so now we're at 4 hours. I took a break. But let's see how many Azure functions I ran. And it looks like I've got 5 of them. So I've got 5 runs. And this is good, right? So this just gives me a pretty clear indication. Maybe you're curious how often your Azure function is executing in a given day. This would be a good query for that. And so it gives you some kind of idea in terms of usage. Now, there's a really important column here, operation ID. And this actually gives you the full sequence, right? So in an Azure function run, for that single run, every entry associated is going to have the same operation ID. And so let's take a look at one of these. I'm going to look at this one. So I'm just going to move down a couple of lines, and I'm going to paste this one in, which is pretty easy. I could type it out, but I want to save time. So I'm saying where operation ID equals this one. So it's going to be this run. And I want to see all the events associated. So this gives me a nice view of what happened during this run. And I can just kind of walk it and see what happens starting from the very bottom, right? Because that's when the function starts. So you can see I'm attempting to retrieve secrets. I'm good there. I've got the 200. And I keep going up. So I've got my successfully retrieved secrets from Azure Key Vault. Remember, that's that login.info I specified, or that was already in my code. And connecting to SQL. And boom, there's that exception from earlier. So let's see what happens. So now I can come in here and see. So yeah, if I look at this exception, expand it out, you can see is not currently available, that particular database. So it looks like the exception was because of a timeout. And I think that might be because of the way I created the database. I know the most cost-effective Azure SQL database option, I think I chose that one, which means that if it's not in use, it's going to spin down. And so when it starts to get used, it's going to spin back up. And I think that's the delay. So anyway. So you can see I got the connecting and I got the exception. So let's take a look at one of the other operation IDs from the Azure function run to see what the full function run looks like, assuming there's no exceptions. So in here, I can just change the operation ID, which I copied off earlier. And all right, and this is a run where everything was successful from start to finish. So again, pulling from Azure Key Vault, we're successful. Now connecting to SQL, we were successful. We submitted that query, right? So from the first Azure lab, you remember doing this. And in fact, remember those logging entries? So now I can see all the entries coming back from SQL because I'm logging those in my code. And finally, I'm successful, and I finished execution. So this is it. I hope this was helpful. It was a good intro into leveraging this really cool functionality. So this can help you in multiple ways, from reviewing performance of the Azure function as well as debugging later on. So I hope you find this helpful, and thank you.